All right, so we're going to solve by substitution. I'm going to isolate one of the variables and substitute it into the other. In this particular problem, I already have an isolated variable. The y is isolated. Everywhere I see a y in the other equation, I'm going to replace it with 3x. So that first equation becomes 4x plus 3. I won't write y. I will write 3x equals 26. Okay, now I only have one variable in this equation to solve for, so now I can do it. So this is 4x plus 9x equals 26. 4x plus 9x is 13x equals 26. 26 divided by 13 is 2. X is 2. Now I go to the second equation, because that's going to be the easiest one to substitute back into. I can substitute back into either equation. I have y equals 3 times x, so y is 3 times 2, so y is 6. So the solution to my system is y is 6, x is 2, and I can write that as an ordered pair. These two equations, these two lines, intersect at the point 2, 6. Okay, so that's substitution. Then we had elimination. You learned elimination. I'm going to skip over the word problem for right now and go to elimination. Elimination was when you usually had two equations that were in standard form, and you notice that you have a couple of coefficients that are opposite of each other, and then you add the two equations together, or sometimes you subtract. However you can make the variable eliminate. So on this one, since I got a positive 3x and a negative 3x, I add. If they were positive 3x and positive 3x, I would subtract. And I get 3x plus negative 3x is 0. Y plus negative 2y is negative 1y equals negative 9 plus 12 is 3. Oh, well, negative y is equal to 3. Divide both sides by negative 1. Y is negative 3. Halfway there. Then I will take either equation, solve that negative 3, and substitute that negative 3 for y and solve for x. I'll take the top equation, 3x plus negative 3 for the y equals negative 9. Add 3 to both sides, and I get 3x equals negative 6. Divide by 3, and x equals negative 2. My solution is x equals negative 2, y equals negative 3, or you can write that as the ordered pair, negative 2, comma, negative 3. Okay, so that's simple elimination. Then elimination method got more difficult. When I didn't have the same coefficient or the opposite coefficient on either of my variables. Okay, so if that didn't happen, we use a different trick. So let's say I'd like the same coefficient on these m's here. So if I multiply the top equation by 3, the coefficient from the bottom equation, and I am writing on it. Oh, I'm tricky. And then I multiply the bottom equation by the coefficient from the top equation. And I'd like to be able to add, because I like to add better than subtract. So I think if I make this a negative 2, I can make either one negative. I'll have a positive 6m and a negative 6m. I'll be able to add the two equations. And so let me do the multiplication. 3 times 2, I got a 6m plus 3 times 4, 12n equals 3 times negative 4, negative 12. It's always that the constant that you forget to multiply times the number. And then negative 2 times 3 is negative 6m. Negative 2 times 5 is negative 10n equals negative 2 times negative 3, positive 6. All right, I add. The m's eliminate. Yes, sir? Oh, there's a 3 here on the bottom, so I multiply the top equation by 3, and the 2 from the top equation goes to the bottom equation. Yeah. Make one of them negative so that you get one positive and one negative 6. You don't always need to do that depending upon the signs, but try. For me it's easier if I have to add at this step instead of subtract. All right, 6 minus 6, that cancels. 12 plus negative 10, that's 2n equals negative 12 plus 6, negative 6. Divide by 2, and n is negative 3. Substitute that back into either to any of these 4 equations. I go for the simplest ones. I'll go for the top one. 2m plus 4 times negative 3 equals negative 4. So 2m minus 12 equals negative 4. Add 12 and get 2m equals 8. So m is 4. So the solution to this system is m is 4 and n is negative 3. You can also write these in an ordered pair, but since they're not x and y's, we should tell which is m and which is n. So m comma n is equal to 4 comma negative 3 would be the way to write that. Or you could write n comma m is equal to negative 3 comma 4. So if I just wrote the ordered pair, I wouldn't know which one was m and which one was n. Okay. Then they get a little trickier. Let's try these two. These are going to be trig equations. So if I'm going to solve this first one, it looks like I could just multiply the second equation by 2 and I would get the same coefficient on the x. So if I only have to do one multiplication, I'll just do one multiplication. So I'm going to multiply. I'm going to change pen colors here. If I multiply the second equation by 2, I get, the top equation by 2. That'll give me negative 6x. I won't have to multiply the second equation by anything. So negative 6x plus 10y equals 12. And 6x minus 10y equals 0. All right. Add them. Negative 6x, positive 6x, that's 0. 10y minus 10y, that's 0. 0 equals 12 plus 0 is 12. My variables are gone, and I have a false statement. If my variables are gone and I have a false statement, no solution. The lines are parallel. Okay. The same thing's going to happen with this other one, except we're not going to get the no solution. But we're going to lose our variables in this other one. So I'll multiply this top equation by 2 to get negative 6 and 6. So I get negative 6x plus 10y equals 12. And then I had 6x minus 10y equals negative 12. When I go to add 0, 0, I get 0 on the left side, and 12, negative 12, I get 0 on the